All right, friends and neighbors, welcome back to another networking video. We are talking about network address translation. So today we're going to talk about a couple more example topologies and then maybe get a new tool in our toolbox. So let's go get them. NAT part 2. Now, of course, before we get started, we want to remember our RFCs and maybe what we did last time. So the two important RFCs to us are RFC 1918 and then RFC 3022. 3022, remember, replaces 1631. And RFC 1918 is the RFC about the private internet address space. From that we get the 10 NAT, 172.16.31, and 192.168. And we also previously sort of defined the traditional translator as one that takes everything from the inside network and translates it to one address on the outside of the NAT box or the NAT router. But even though that's the traditional translator, we also know that there are lots of flavors of NAT where we can modify the behavior of network address translation to translate to one address, a particular set of addresses, or access control lists can be part of the conversation as well. So it's not just that we have one flavor of NAT. In addition, we have the routing process and then we translate. And so even through a single NAT box, we can have both. We can have traditional routing and traditional network address translation, or a modified network address translation. And we'll do an example of that here in a minute. So this was the topology that we previously worked with. Remember that we have, our private address space on the inside. So we're defining the private address space as also the inside, and that's 192.168.1.0. That's our network there. And then we've got our default gateway for all of those nodes, and so that's 1.254. And this NAT router, it's a 2811 in packet tracer, but remember, this is exactly the same as what your wireless home gateway or your wired home gateway does in your house or in your apartment. This is exactly what's going on. So you can replace this with your Linksys or your D-Link box. On the outside, we've got our public address space. Now, we said before that we could do private to private translation, public to public translation. You could, but to keep things sort of straight, in our examples, we're going to do straight up private to public translation. And so we're going to define the public as the outside here, and I was pretending to be Google, so we've got the 8net on the outside. Okay, now for the examples that we're going to do today, what we want to do is add to this topology. We want to add a few more nodes and see what happens. So let's do that. And here is our friend Packet Tracer. And so all that I'm going to do right now is add a couple of nodes to the inside. So we'll do, maybe we'll move this a little bit. We'll put this guy here. And we'll move, I think 3 ought to do it. And we're just going to connect to the same switch. We're not doing anything special on the switch, so it doesn't really matter. There we go. Maybe we'll say, we'll make this 192.168.1.2 and 192.168.1.3. See, nothing up my sleeve. Okay, now we got to do the configuration, right, for these hosts. So the default gateway will be the same as the other nodes. 254, 92.168.1.2, and the mask will be the default for a class C. And again, 192.168.1.254. 1.3. Now, why am I adding so many nodes? Because we want to see the impact of a couple of our choices here. Now, let's recall ourselves to a couple things, right? Here is our NAT router. And if we take a look at our configuration. Show run. Oops, that's not going to work. We can see that we did a static mapping. All this line says is I'm going to map 1.1 to 8.8.8.254. And this is very traditional approach to this. I could have used any valid IP address, as long as nobody else was using it, on the outside. And so last time I think I used 99. And then we also said we've got our IP NAT inside, we've got our IP NAT outside, and the two addresses. And so the translation was actually very, very straightforward. Well, what happens if I modify this a little bit? So we want to see, we're trying to understand the behavior of NAT and the routing involved here. To actually see this behavior, let's run our simulation again. All right, so we have to remember, right, we're translating here. Maybe I'll even move this stuff around so we got a little more room to type things in. Let's see things front and center. There we go. And we're going to do our simulation. And what we want to see, we just added a couple of nodes, right? What happens when we generate traffic from these other nodes? So we know that we're going to go back to ping here, and we'll cover something else with ping. All right, so I'm going to ping 8.8.8.8 again. And we got to wait for ARC to update. All right, so now the ICMP goes, and we're going to ARC on the other side. But what we care about is PC0 sends this out, and we know when it does that, we've got 1.1 going to 8.8.8.8. But what is it on the outside? All this ARPing to be updated. Here we go. All right, now we're on the other side, right? What does it look like there? There is no 192, and what that tells us is that it was translated, right? So the NAT router took that packet that was sourced from 192.168.1.1, replaced the source IP address, recalculated the header checksum, and then substituted itself. So now on the outside, PC1 believes it's communicating with 8.8.8.8. That's really, really important for us to remember. So now the transmission comes back, and so it's on its way, right? It's on its way. So now PC1, who is it responding to? It is responding to, right? The address is just flopped. It's heading back the other way. It's responding to 8.8.8.254. And as we step through this, it gets remapped to the inside so that this transmission going back to the host is back to 8.8.8.8 and 192.168.1.1. Okay, that's what we did last time, and that is very traditional NAT. It is single instance. We're going to go back to real time here. And what keeps track of all that? Our translation table. Okay. Now, one thing that's a little bit of a mystery for this is, what is this number right here? If you saw this written anywhere else, we would assume that that's a port number. But ICMP doesn't have port numbers. ICMP is part of the IPv4 suite. So it's a protocol that runs at layer 3. So where in the world do these numbers come from? Well, let's take another look at our transmission. We're going to do it again. And what we want to do now is take a look at the contents of the ICMP header. So I'm trying to fit this on the screen here. So we see Ethernet up here. This doesn't have anything to do with our translation. Get destroyed on one side of the router, we build another one. Here's the IP header. That's where we're doing all the rewriting. And there's nothing really that's interesting in here, except maybe we got the protocol ID, right? Then we've got this sequence number down here. What's that about? Now we do have an ID that's up here. This is the fragment ID, but I don't want to confuse us because what's really happening is that we are worried about the sequence number. So if we let this play out a little bit, I'm just going to minimize this a little bit. We'll let this go just a few because we want to see what's happening. We'll take another look at this guy. What we're really keeping track of here is the sequence number. Now, Packet Tracer confuses this just a little bit because when you're looking at actual packet capture, this ID is a random value. But what we're really after here is the sequence number. Packet Tracer happens to be tracking them together. But that's really what we care about. So now if we go back to our translation table, right? These were all of the IDs that were going across now. So the important detail here is that this is not a port number, but when you're pinging through a NAT box, we got to have some way to keep track of the transmissions. And in fact, all of this PC could have sent multiple ICMP streams to the same destination. How would you keep them straight? And it would be with this sequence number right here. So that's what we're seeing in a translation table. Okay, so not a port number. Okay, that match between the sequence number in the ICMP header and the IP header was bothering me enough that I wanted to do an actual ping for you. So here we go. This is a ping that I just did to the real 8.8.8.8. This is from my host out, and here is the ICMP exchange between us. Here is the identification for the IP header. It is this random number. The hexadecimal is D2DB, or 53,979. But now take a look at the sequence numbers that were used by this transmission. Okay, so these were the identifiers here, and that's what network address translation actually keeps track of. Okay, so that is an important detail, and I just wanted to make sure that we had that straight, because Packet Tracer can make that a little confusing a little bit. Okay, so another example why simulation is not always real life. Okay, back to our network address translation. Well, now what happens when we generate traffic from one of the other nodes? So I'm just going to, we'll do our simulation again. And we're going to do the exact same thing. We're going to ping, but this time we're going to be pinging from 192.168.1.2. This is not real life, this is in Packet Tracer. Alright, we're stepping through. We got ARP again because this poor node has never been part of the topology. Okay, so here goes the transmission on the inside part of our network. And we can see, no surprise, 192.168 to 1.2 to 8.8.8.8. Okay, so that is what we did on the command line. And what is it on the outside? So there it is on its way to that PC. Oh my goodness, there is 192.168.1.2 to 8.8.8.8 on the outside. So this traffic was routed and not translated. So in this particular case, right, we'll go back to real time, get all this stuff out of the way. In this particular case, this node was routed and translated. This node's traffic was just routed. And the same thing would happen with PC3 here because we haven't had any statements that describe how it's going to do things. Okay, well that brings us to our next one. We've done static. We know exactly how that works. Whoops. Okay. Let's do a pool of addresses. And so for that, what we're going to do is we're going to say, well, listen, on the outside interface, instead of specifying a particular address. What we're going to do is we're going to say, listen, when you're translating, just pick an address from this pool of addresses, and we'll do it that way. So let's do that configuration. Now I'm going to get rid of my previous translation so that that's not in the way. Copy that and paste it. There we go. So that gets rid of it, and so everybody's just being routed now. So now let's do our IPNAT commands for our pool. So previously we played around with IPNAT sources. So now what we're going to do is build a pool which sort of jumps ahead of that a little bit. So we're going to do IPNAT. Now whenever you get confused on this kind of stuff, you can always do the question mark. Previously we were saying the inside, but what we're now going to do is a pool, right? And we're going to define a pool. So this is going to be a similar process that we do when we use an access list. So we're going to say a pool. What are we going to do? Well, we're going to call it, I don't know, my pool. And then it wants us to do a range of addresses. So now you can get really nutty here. We are going to use the valid IP addresses on the outside interface. And so maybe just to make a distinction, we'll say, since it's the entire 8net, we'll do 8.8.8. Well, we'll do 91, okay? And maybe because we got 3 addresses, we'll just keep it to those 3. So we'll do 8.8.8.93. Now, if I had made this shorter, right, and there were not an address available, we would get results that would be the mix between translation and routing. But we're gonna have enough addresses for everybody. So let's go ahead and specify the net mask. Just have that. 255. Oh, there we go. And we're done. Okay, so now if we do, let's see, we'll do a do show run. So we have this pool, but we have a problem. We're not really using the pool at this point. So now what we're going to do is make our actual NAT statement. So to activate our pool, let's do one more thing. And for that, I'm going to create an access control list. We will use this again later on. But let's say that we do something like this. We'll say access list. We'll make it really clear. So I'm going to do access list, whatever number, 43. Now that number is important because that makes it a standard access list. So that all that we're examining here is the source IP address. If I was to use a number between 100 and 199, I would be examining more fields. And so what I'm just going to say is, well, we'll do our question mark again, but what we want to do is permit the collection of addresses from the inside. So you can see that here is my choice. And so I'm going to say I want to permit. Well, what am I going to permit? Well, in this case, I'm going to permit the addresses from the inside. And maybe, now we're using a pool, so we'll do all of them for right now. So we're going to permit 192.168.1.0. Let's use a wildcard mask for that. We don't necessarily have to do this at this point, but we're going to go ahead and do that. And then that's pretty much our access list. Now, we're not using this access list, and we're not using the pool now. So let's see if we can glue them together. And the only thing that I'll add at this point is that if I had made this access list to specify 1 or 2 of these hosts, then what would have happened in our natting? Well, again, I would have translated some, and I would have routed the others. And how's that work? Because it's not a firewall rule at this point. It's just a container. It's just an access list. All right, so let's put the two together. So we're going to say IPNAT inside source what? Well, now we want a list. So we're going to say we're going to use what list? Well, what list did I create? I created 43. Okay, well, now what are we going to do with it? Well, I could use a variety of things. I could go to the interface now and just say, here's what I want you to do on the interface. We'll do that in a little bit. But what we're going to do is we're going to specify the pool. Well, what pool? Well, I created one earlier, right? My pool. And that's pretty much it. We're going to go ahead and say that. We'll use overload later on. But there we go. Now let's see what happens. Remember that our overload list is what? 91, 92, 93. So for this, we're going to want our simulation again. And we're going to ping 8.8.8.8 from 1.1. And what is it doing on the outside? Well, there's 91 right there. That's nice. I like that. Let's see what happens when we go to, we'll go to real time again. Save a little time. Let's do them out of order to see what happens. So I'm going to do ping again, 8.8.8.8. All right, so it's working. Let's go to simulation. That just gets me out of waiting for all the art stuff again. Okay, so we're going to step through. So on the inside, we have, oh, I caught it on the outside. Let me go back to the inside. There it is, 1.3, 8.8.8.8. Okay, so what is it on the outside? 8.8.8.92. That doesn't match. This is PC3. This is 1.3. And the reason that it picked this is because it just grabbed the next one in the pool. And so we've got 8.8.8.92 going to 8.8.8.8. Okay. Well, let's keep the party going. I'm going to add PC2 into this. And we'll just have to watch our colors here. Or just where they are in the transmission. All right, so if you take a look at this, this came from the NAT router to switch 1, so we know that it's heading in a particular direction. And if you can see the colors, then we know that this is, what is that, like sort of a bronze. And we can see that it grabbed 8.8.8.93, and then we went to 8.8.8.8. So there you go. And now let's take a look at, we'll go back to real time, and just for fun, we'll keep checking back with our translation table. Show IP NAT translations. Oops. Okay. Oh, look at this. Now we've got all of these addresses sourced from the inside, right? 91, 92, 93. And these are all of the different translations that were done. So now this router is keeping track of a whole bunch of translations. Okay. Well, let's do one more thing as long as we are here. Remember that we did this IPNAT inside source list 43 pool my pool. Well, I don't have to do that. I can say, well, instead of this using the pool, I could just say what? I could just say, let's use the interface. Well, what interface are we translating on? Well, we're translating on the outside interface, this one here. So I'm going to say, remember that this is the way that I do things, it's F0/0. So this will be F0, F0/1 is my outside interface. Maybe just to be clear, I'll do that. F0/0, like that. And this is F0/1, like that. Okay. So now what I'm going to do is I'm going to say, look, I want you to translate on F0/0, and I'm going to add the keyword overload. All right, let's see what that does. So again, we're pinging from 1.1, and we'll just pings away, and we'll ping from here as well. Do another ping, and another ping. Okay, so without looking to see what actually happened, what do we think ought to happen? The pool is still on the router, but it's not being used. The access list is on the router, but the access list just said, I'm going to name these three hosts, or really the entire network address inside, and we scooped up everybody, and then we just specified that the translation would be going on the interface. So what does the router translation table look like now? Oh, complete change to the translation, the inside global, that is to say what everybody's using. But look at all the IP addresses, 1.2, 1.3, 1.1. All of them are being translated to the same address. Well, let's run our simulation here and see what this looks like. Well, again, we'll just do the pings from everybody. All right, so everybody's pinging. Okay. And we're going to run our simulation. Here they all go. And they've all, there's 1, 2, 3. Okay, so now we want to see what's coming from the router. And so to switch 1. So we'll grab this one first, I guess. The outbound, 8.8.8.254 to 8.8.8. Well, what's this one say? From the same IP address, going to the same destination. Oh my goodness, what's happening? And again, 8.8.8.254, 8.8.8.8 is the destination. And the way that the router keeps track of all of these, because now we've got these transmissions all coming back, but what do they have different? They have a different sequence number in the header, and so that's how the router keeps track of them. Okay, we'll go back to real time here. Well, ping is fun, ping is nice, but it's not really layer 4 traffic, is it? So how do we see what actually happens when you're doing TCP-based applications or you're gaming or anything else? And the answer is that now we need, we'll use PC3 just to make life a little interesting. Now we're not going to use the command prompt. Now we're going to use a traffic generator. Okay, well, what are we going to do? So maybe we'll use HTTP, right? We'll use straight up port 80 on this, and we will say that the destination will be 8.8.8.8. And our source IP address, well, that's pretty straightforward. It doesn't have to be, right? It's just a traffic generator. I'm going to use the IP address that's here just to sort of keep things straight. But it's traffic generation, so I could use anything I wanted to here. Now the starting point. Now remember that if you're talking about TCP and UDP, the system ports, or the well-known ports, are those below 1024. And that's why we've got a destination port of 80. But if we're a client, we're going to generate a random port somewhere above that. Now this is a traffic generator. It's not really a random port generator. So I'm just going to obey the rules, and I'm going to not use a system port for my source. And we'll just do, maybe we'll do periodic. We'll do every 1 second. There we go. All right. So now what this is going to do is it's going to send TCP traffic periodically across to my destination host. And we'll go to the simulation so we can see what's happening here. Now you can see over here, these are TCP messages now, or TCP packets, datagrams, and off they go. And interestingly enough, PC1 looks like it's responding. Okay? But of course we've got the translation in there, so who is it responding to, or to whom is it responding? Well, it's responding to this IP address right here, but if we scroll down a little bit, we've got our TCP header, and we've got our port numbers, 80 and 2000. Remember, this is going back from the destination back to the source, so these are flopped. Maybe we'll grab the one that was outbound. So here's the outbound, 1.3 to 8.8.8.8. Remember, on the inside network. There's TCP, and here's our source port and our destination port. So this is an excellent way to generate a different kind of traffic and fool around with layer 4 ports. And there's our conversation back to PC3. All right, well, what does that look like on a translation table? There we have it. So this is going to, it's TCP, and it's notice that the ICMP here, right? So that should have been a dead giveaway that we weren't using port numbers before. Now this is TCP, so now our translations are those unique 4 numbers, right? The matched pair of matched pairs. Source and destination IP address, source and destination port number. So here we've got where you were going, right? Well, I guess we'll start from scratch, right? So this is the inside. And then we are going to this particular destination, and then it arrives at the outside global address of 8.8.8 and port 80. And there we see the colon port numbers. Okay? So when it comes back, it's coming back and the router gets it and says, oh, I just got this. Where is it supposed to go? Oh, it's supposed to be remapped to this one here. And on the outside, what does it actually look like? Okay, so that is a brand new tool. We can stop this now. And here we have the traffic generator, and you can pick a variety of protocols that you want to use. Now we're getting really long here, so the thing that I'll point out lastly here is that if I was going to run a server on the inside here, what would I need to do? How would I do protocol address translation? Well, what we would need to say is that your outside node is not actually communicating with the inside node. It's going to communicate with the outside address and the port number, right, that you're using for this transmission. So this host on the outside, PC1, doesn't actually realize that it's communicating with PC3. It thinks it's communicating with 8.8.8.254, and the conversation is happening on port 80 and port 2000. So when PC1 responds, it sends it back to 8.8.8.254 colon 2000, because that's where it believes the source is. And the translation table remaps it. That is protocol address translation. That's what your D-Link or your Linksys at home does when you're setting up a server or you're playing a game. Somehow, the node to whom you are communicating must understand the outside IP address and the outside port numbers. And then your router will translate those to inside. So maybe as hint, hint, wink, wink, maybe next time we'll talk about stun and turn servers. All right, that'll about do it for now. So our new thing today was, a traffic generator that can actually generate layer 4 traffic, and that will be TCP or UDP port numbers, actual port numbers that now you can see in our translation table. Because the important thing about a translation table is that it's not really worried about ICMP traffic. That's not really the name of the game. We're usually doing application. We're usually worried about port numbers. And those port numbers are actually going to be what's translated, especially on the inside to the outside. But if you were running a server, then the outside client has to knock on the door on the outside of the NAT box and say, please would you translate this for the server? And that's what we can start to work with when we deal with the packet stream generator. Well, this has been more NAT goodness, right? We've done a couple of NAT flavors. We've done some protocol address translation. We actually got to see that. The only thing that we didn't do is run a server and then see a client connect to a server. That's a little challenging in Packet Tracer. But we did get to look at some traffic generation and those actual port numbers. All right, like and subscribe to celebrate your now phenomenal cosmic NAT powers. And whether you're doing static mapping or pools or overloading on a particular address, access lists, oh my goodness, may those packets always reach their destination.